Every time your cells divide, they face a simple but critical challenge, protecting the integrity of their DNA. At the ends of each strand of DNA are structures called telomeres. These act like protective caps, helping preserve the genetic information inside the cell. But each time a cell divides, these caps become a little shorter. Over time, as telomeres wear down, cells lose their ability to divide, repair, and function properly. This process plays a major role in how we age at the cellular level. Understanding telomeres helps us better understand why aging happens and what it takes to support cellular longevity. Telomeres are protective caps located at the ends of our chromosomes. You can think of them like the plastic tips on the ends of shoelaces. They help keep the DNA from fraying or becoming damaged. Their role is to protect the integrity of our genetic code every time a cell divides. But there's an important detail. Each time a cell divides, telomeres become slightly shorter. Over time, as they continue to shorten, they lose their ability to fully protect the DNA. This gradual shortening is a natural part of aging, and it plays a key role in how long a cell can continue to divide and function properly. So while telomeres protect our cells, their decline also helps determine the lifespan of those cells. Telomeres play a critical role in protecting our DNA and maintaining cellular stability. Every time a cell divides, it relies on telomeres to help preserve the integrity of its genetic information. They not only protect the DNA from damage, but they also help support proper cellular repair and function. But there is a limit. As telomeres continue to shorten over time, cells gradually lose their ability to divide and repair effectively. This is one of the key reasons why tissues begin to age and lose function. Shortened telomeres have been strongly linked to aging, reduced cellular resilience, and an increased risk of disease. In contrast, longer, healthier telomeres help support stronger, more resilient, and longer-living cells. Every time a cell divides, its telomeres become a little shorter. At first, that shortening may not seem like a problem, but over time, as telomeres continue to wear down, the cell begins to lose protection. When telomeres become too short, the DNA is more vulnerable to damage and instability. At that point, the cell can no longer divide or repair the way it once could. This contributes to slower healing, reduced cellular function, lower resilience, and greater fatigue throughout the body. As more cells reach this stage, tissues begin to age faster and become less efficient. Very short telomeres are also strongly associated with increased inflammation, chronic disease, and accelerated biological aging. In some cases, when telomeres become critically short, the cell enters a state called senescence, where it stops dividing and functioning properly, or it may die altogether. So while telomere shortening is a natural part of life, the speed at which it happens plays a major role in how well cells and the body age over time. Telomere shortening is a natural part of life, but certain factors can cause that process to happen faster. One of the biggest drivers is chronic stress, which increases stress hormones and places more wear and tear on the cell. A poor diet can also speed telomere shortening by depriving cells of the nutrients they need for protection and repair. Lack of movement or exercise reduces circulation, metabolic efficiency, and the healthy signals that help support cellular resilience. Poor sleep is another major factor, because sleep is when much of the body's repair and recovery takes place. Smoking and environmental toxins increase oxidative stress and inflammation, both of which can damage DNA and accelerate cellular aging. Over time, these stressors can cause telomeres to wear down more quickly, making cells more vulnerable, less efficient, and less capable of healthy repair. So while telomere shortening may be inevitable, the rate at which it happens is strongly influenced by how well we support the cell. While telomere shortening is a natural part of aging, the good news is there are ways to help protect them. One of the most powerful factors is managing stress. Chronic stress places a heavy burden on cells, while stress reduction helps create a more stable, supportive environment. A healthy, nutrient-rich diet provides the building blocks and antioxidants cells need to protect and repair DNA, less efficient and less capable of healthy repair. Regular movement and exercise help improve circulation, support metabolism, and send positive signals that strengthen cellular resilience. Sleep is also essential. During sleep, the body carries out many of its repair processes, including those that help protect DNA. Reducing exposure to toxins, such as smoking and environmental pollutants, helps limit unnecessary cellular damage. And even factors like social connection can play a role, helping to reduce stress and support overall well-being. Together, these habits don't stop aging, but they can help slow the process and support stronger, more resilient cells over time. When we step back and look at the bigger picture, telomeres help us understand an important truth about longevity. Telomeres protect the DNA and help support cellular stability and function. But each time a cell divides, and each time it is exposed to stress or damage, those protective caps gradually become shorter. As telomeres shorten, cells become less resilient, less efficient, and less able to repair and renew themselves. That's where lifestyle becomes so important. The way we eat, move, sleep, manage stress, and reduce toxic burden can all influence how quickly this process unfolds. In other words, telomeres are not just passive markers of aging. They are part of the story of how cells age over time. By supporting the health of our cells, we may also help support longer, healthier, and more resilient lives. Telomeres are much more than just markers of aging. They are deeply connected to the health, resilience, and lifespan of our cells. As telomeres shorten, cells become less capable of dividing, repairing, and maintaining stability over time. That's why shortened telomeres are closely associated with cellular aging, reduced resilience, and increased disease risk. But one of the most important things to understand is this. Telomere health is not determined by time alone. The way we eat, sleep, move, manage stress, and reduce toxic burden can all influence how quickly this process unfolds. So in many ways, telomeres reflect the condition of the cell itself. And when we support healthier cells, we help support healthier aging. Because in the end, healthy cells are the foundation of a healthier, more resilient life. But telomeres are only one part of what determines how long and how well a cell can function. Even a protected cell still needs the energy and cellular fuel required to repair itself, communicate properly, and stay alive. And that brings us to another major player in cellular aging and longevity. NAD, a critical molecule that helps power repair, energy production, and cellular survival. If you'd like a simple guide that shows you how to support these cellular systems and improve your health step by step, we've put together a free resource you can use right away. Just click the link below, enter your email, and we'll send it directly to you.